Hi, everyone. I'm John Yap. I'm the product manager for WaterTrax. First of all, I'd like to thank all of you for taking time out of your busy days to join us today as we present the new Formula Builder tool. Formula Builder is a tool embedded in WaterTrax that will provide you, the users, with the ability to manage and automate the process of calculating formulas to satisfy certain regulatory requirements you may have. The agenda over the next half hour will look like this. I'll start off by giving you an update on WaterTrax. Then I'll be giving you an overview of the features and benefits of the new Formula Builder tool, followed by a demonstration of the new tool. And then we'll do a quick recap of what we've covered. So as many of you know, WaterTrax has been around for quite a long time now. In fact, this year, we're going to be celebrating our 14th year anniversary. We now have over 130 agency and municipal clients, including each and every one of you, that control over 3,500 water and wastewater systems around North America. We also have over 100 partners consisting of government and commercial labs across North America. WaterTrax is committed to helping municipalities, utilities, and public agencies deliver safe drinking water to the public and ensuring clean wastewater is put back into the environment. Because of this, we're also committed to maintaining and improving our application with the development of new features and functionality to enhance your user experience, which hopefully will make it then easier for you to perform your job duties. We're very proud of the relationships we've formed with each of you over the years, and we appreciate your continued support. So now for the main topic of today's webinar, the Formula Builder. What is the Formula Builder? Well, the Formula Builder is a tool for performing calculations within the drinking water and wastewater data management modules of the WaterTrax application. The tool lets you build a library of calculations that you're required to perform on a regular basis to satisfy regulatory requirements. This means with this new tool, you're no longer going to have to perform these calculations in your Excel spreadsheets and having to input the results into WaterTrax as a secondary step. You can create calculations in a couple of ways. First, you can select from a function from a drop-down list of predefined calculations that we built into the application, many of which are commonly used functions within the industry, which I'll show you in a bit. Secondly, you can also customize your formula by manually defining your equation using mathematical operators and inputting it into an equation box. Some of the key features of this tool includes a formula validation mechanism to ensure your formulas are valid and are mapped to the correct measurements in WaterTrax, having the flexibility to specify the unit output and the decimal place rounding of your results, having a built-in library of predefined functions, and because the tool is embedded in the WaterTrax application, this means that the values being used in the calculations are being drawn from existing measurements in WaterTrax that regularly receive data from your laboratories. So what are the key benefits of this new tool? Well, first, it's highly intuitive. The tool is easy to set up either by selecting from a predefined list of calculations or customizing your own equations. Secondly, the tool is automated and will trigger calculations on a regular scheduled basis based on certain settings that you've chosen. This means your calculated values are ready to be reported at the beginning of the month or quarter or any other particular date range you've specified. Third, the tool makes the process of calculations seamless since it is fully integrated with the application, meaning you can use this tool and still take advantage of the other core functionalities in WaterTrax, such as alerting for any potential exceedances within your results and reporting using one of the many reporting tools available in the application. Lastly, the tool will improve your accuracy and reduce errors since formulas are being validated. They run automatically and they're being stored directly in the WaterTrax database, thus eliminating the need to re-enter any data from your Excel spreadsheets. Once again, there are two ways you can create calculations using the Formula Builder tool. The first is through predefined functions, which include some of the commonly used calculations in the industry, such as averages, medians, and maximums. And we're also going to continue to add to this list moving forward. The second method is through customized formulas, which you can manually define based on your own specific needs by using basic mathematic operators such as adding, subtracting, multiplying, and dividing by using any of these symbols here. Examples of calculations that you can formulate using the manual approach include F2M ratios, TTHM or HA5 quarterly averages, removal efficiencies, as well as loadings. Here's a quick illustration of the user interface for creating a formula in WaterTrax. As you can see, it's very intuitive, and it's actually similar to how you would go about adding a new measurement in WaterTrax now. So that should look quite familiar to you. Beyond just having the ability to select your function or define your formula, you'll also be given the flexibility to select the units of your result outputs, as well as the number of decimal places to which results are being rounded up or down. With this tool, your complex calculations are simplified. You're able to perform multi-level calculations, or in other words, calculations within other calculated results. An example of this is an average mass loading, for instance, where you can choose to calculate the loading value first, followed by calculating the average of those loading values, or vice versa. You can also use as many component measurements as you require in your formulas. This means you can perform calculations taking results from as many data sources as you need. You can round results to the appropriate number of decimal places. And finally, component results are converted according to the pre-selected measurement unit, meaning that if your lab, for instance, ever makes a mistake of uploading results using different units, you can be rest assured that those results will be converted to a base unit first, so that your calculated values are not affected. The Formula Builder complements existing features of WaterTrax, thus allowing users to manage their data, starting with the first step of creating the measurements, then to the next step of generating the calculated results, and finally to the output of these values via our reporting tools, which, by the way, of course, you can manipulate even further if you require before submitting to your regulators. Each step within this process of management is consistent with how other data is managed in WaterTrax. So at this point, I'm going to go ahead and switch gears and start to demonstrate the new tool to you. And for this, I will be using one of our internal demo accounts. So first of all, this feature has been enabled on all your accounts, including both agency and utility, as well as drinking water and wastewater. Just like the calculated measurements, the formula measurements are also assigned at the measurement level of the hierarchy tree or structure. This means that the first step in the process of creating formulas is to navigate to the sampling point where I want the formula measurement to be added. So let's go ahead and find the right sampling point. And I know it's within my wastewater treatment plant, and it's my effluent sampling point. Once I'm at the right sampling point, I can click on the Add Measurement button up here on the upper right-hand corner. Next, I'm taken to a page that should be familiar to a lot of you. From here, we would simply go through defining the attributes of this measurement the same way we would any other measurement, starting with the name. So let's give it a name. Call it Demo 1. Then the reading type. In this case, we're going to select calculated as our reading type. And of course, this is also used by existing calculated measurements. Then as you can see here, the next drop-down list is the Analyte drop-down list, and we have a new option available called the Custom Formula. That's the one we're going to want to select. Notice that as soon as I select that one, a set of fields underneath dynamically appear. And at this point, the next step is for us to decide what type of calculation we want to create. Namely, is it a function from the drop-down list of predefined calculations, or do we want to manually type in the equation into this equation box here? In this first example, I'll go ahead and select a function from the drop-down list. And I'm going to select the AVGM, which stands for average monthly. Notice that when I hover over any of these choices, you can see a tooltip that comes up. This tooltip is quite handy as it explains how each function works and provides you with a quick definition of each one as well. So I'm going to go ahead and select AVGM. Notice that as soon as I select it, it populates the equation box with the function followed by an open bracket symbol. What we need to do next is select or enter a component measurement locator to be assigned to this formula. What is a component measurement? Well, these are measurements that exist in WaterTrax that contain result values. Essentially, the component measurements used in a formula determines what values are being calculated and where these values are being taken from. So in this case, since I want to calculate my monthly average for TSS, total suspended solids, this means my component measurement will be a TSS measurement, which I know receives data from my lab regularly. So there's a couple of ways I can assign a component measurement to a formula. First is by clicking on this select measurement link over here, which acts as a lookup function, then choosing the appropriate sampling point, clicking on next, and then choosing the right measurement. And as I said, we're going to select TSS lab report, which is where most of my data is located. Let's go ahead and select that. And as you can see, as soon as I select that measurement, the measurement locator is appropriately entered into the equation box, preceded with the letter C. That letter C is mandatory as it is a code we use to recognize a measurement locator. C stands for component. So anytime you're typing in a measurement locator, you would simply input the letter C in front of it. So at this point, all I need to do is input a close bracket and our measurement has been defined. The second way, of course, I can assign a measurement is by simply typing in the measurement locator into this box. And if you are creating several calculations using this tool, I definitely recommend having a list of your component measurement locators handy as your reference guide, as this would make it would make the process of adding these calculations much more efficient. After inputting the component measurement, the next step now is for us to click on this check formula button over here, which acts as a validation tool used to ensure that the formula is acceptable. So if I click it, or click on it, we can see that it's in green. The font is in green, which means it's acceptable. If it's not acceptable or if there's an error, it would show up in red. In this case, not only does it tell us that it's acceptable, it also spells out exactly what the measurement locator is associated with. So in this case, it is TSS, and we also have the units associated with that measurement, milligrams per liter, which is correct. So I'm confident that I've selected the right measurement. After this, there's only two more things that we need to define before we trigger the calculation. The next one is to specify the number of decimal places we want to round up or down the results values to. So in this case, I'll input the number 2. You can input any values from 1 to 10. After that, we're going to select the result units we want to associate with all of our result outputs. And in this case, I'm going to select milligrams per liter, and feel free, this list, as you know, is listed in alphabetical order. So feel free to also type in the first letter or two of that unit you prefer, and it'll jump you to that particular selection. So there's our milligrams per liter over here. Let's go ahead and select that. So at this point, I can go ahead and hit save, and that will essentially trigger the calculation. But before I do, I want to just let you know that this measurement locator I've associated with this formula actually contains over 3 years worth of data. Now I want you to notice how quickly the calculation is processed, and it does back calculate all 3 years worth of data as well. So I'm going to go ahead and click save here. And again, as you see, it took less than 2 seconds to calculate 3 years worth of data. And what we're seeing here now is the alert settings page. You have the option of assigning an alert to this particular formula, but however, please note that if you do assign an alert, you're also going to get alerted for historical data, which may no longer be relevant to you. So in this case, just for the purposes of this demo, I'll leave it to its default setting, and we'll go ahead and back out and go back to our sampling point level. And now we are going to see, we're going to check to see if all the results are there. So this is the formula builder measurement we created, demo 1. It's now a measurement, and I'm going to click on it. And as you can see, there are several results that have been calculated dating back to 2010. So we know that historical data have been calculated, And we also noticed that results were generated on a monthly basis at the end of each month. We have one for April 30th, one for March 31st, February 28th, and so on and so forth. We also noticed that the results are being rounded up to 2 decimal places, which is what I expected to do. And lastly, we see that the units being used is milligrams per liter, which is also what I selected. So we know that the calculation is working properly. So the next example I want to show you is how you can create a formula to calculate running annual average for TTHM samples. This time, I'm going to navigate over to my drinking water module, since that's where I have my TTHM samples. So once again, let's navigate to the appropriate sampling point. This time it's the 1100 Homer Street. Once you're there, you can click on the Add Measurement button, and let's give it a name. Let's call it Demo 2 this time. The reading type will still be calculated. The analyte is also custom formula. And this time, I'll be selecting a different function from the drop-down list. This one called AVGQR, which stands for Average Quarterly Running. The way the function works is if you need to specify, or is that you do need to specify the number of quarters to calculate. Since in this case, I'm looking for my annual running average, I'm going to input the number 4 positioned right after the component measurement locator to indicate the need to include data within the last 4 quarters each time the calculation is triggered. So first, I'm going to need to assign my component measurement. So once again, I'm going to click on our little lookup tool. Scroll over to the sampling point in question, which is 1100 Homer Street. Click on Next and select the appropriate measurement, which is total trihalomethane lab data transfer. Go ahead and insert that, and there's our measurement locator. As I mentioned, I'm going to input the comma symbol followed by the number 4, which indicates the number of quarters to be incorporated into the calculation, which is 4. And at this point, we can go ahead and check the formula to make sure it's valid, which it is here. And as you can see, we've selected AVGQR, quarterly running for total trihalomethane in milligrams per liter. And we have the number 4, which stands for the calculating 4 quarters. So we have the right formula in place. The next, we're going to input the number of decimal places to round up values to. And lastly, we're going to specify the result units, which is also going to be in milligrams per liter. So once we've made those selections, we can go ahead and click Save to trigger the calculation. And once more, I have historical data associated with this measurement. So let's see how long it takes to calculate. And that one took less than a second, which is, again, something I want to emphasize because we have optimized the code to perform these calculations for you. So let's back up and take a look at our results. So again, it's Demo 2. That's the name of the measurement we've created. And here are all our results. There's not as many results because, of course, we've created a quarterly average formula, which means I'm only going to be expecting to see results once every quarter and at the end of each quarter. So here I have a result for March 31st, another one for December 31st, September 30th, and so on and so forth, dating back to December 31st, 2010. The reading results are being rounded up to 2 decimal places, and the units are also in milligrams per liter. So we know that this formula is behaving properly as well. The next example I want to show you is how you can create a custom formula using this tool as opposed to choosing a predefined function. And for this one, I'm going to navigate back again to our wastewater sampling point. So again, I'm using the hierarchy tree to jump back to our sampling point, go back to our effluent sampling point. I'm going to show you how you can create a TSS loading calculation this time. So let's click on Add Measurement once more, give it a name. Let's call this one Demo 3. Same reading type and the same analyte we're selecting here. So this time, instead of choosing a function from this dropdown, we can go ahead and type in our equation into this equation box. So what I've done is I've printed out a copy of my measurement exports or my measurement locators ahead of time, so I have that handy as a reference guide. and I'm going to simply type in the measurement locator for my flow. As you know, mass loading or loading calculation, the formula for that is flow times concentration times or multiplied by or divided by a proper conversion factor. In this case, I'll go ahead and type in my equation for mass loading or for my flow. I've typed in the symbol for multiplication, which is the asterisk symbol, an open bracket again. Now I'm inputting the measurement locator for my concentration result, followed by a close bracket, and then we're dividing it by the conversion factor of 453.59237, which is converting it into my preferred output unit of pounds per day. So there's my formula. Let's check to see if it's valid. And it is. Again, it spells out the formula or the measurement locators that I've input. It's daily flow rate from my SCADA in cubic meters per day. That's correct. Multiplied by my TSS concentration result in milligrams per liter, which is also correct, divided by 453.59237, which is the conversion factor for getting an output unit of pounds per day. So I have the right formula in place. I'm simply going to input a decimal place there, which is 1 this time, and then we're going to select our result output, which of course is in pounds per day. There's our selection. So at this point, we're ready to trigger this calculation. Let's go ahead and click Save. And that one took a few seconds once more. Let's back up and take a look at our results. That one is named Demo 3. There it is. Let's click on it and see what our results look like. So as you can see, we have plenty of results here dating back to 2011, early 2011. And we do receive several results per month. Essentially, each time you have a flow and a concentration result present, the calculation will trigger a loading result for you. And as you can see, our results are being rounded up to 1 decimal place, which is how it's supposed to behave. And finally, the units associated with the results is pounds per day. So we know that the function is working as it should. So the last example I want to show you today is how you would go about creating a removal efficiency calculation by manually defining the formula. So let's back up once more to our sampling point of effluent. Let's click on Add Measurement. Let's give it a name. We're on to our 4th example. Same reading type, same analyte, and once more, rather than selecting a function from this drop-down list, I'll simply type in my formula for removal efficiency, which is 1 minus effluent divided by influent times 100. So I'm inputting my effluent TSS value here, or a measurement locator here. And again, I do recommend that you print out a list of your measurement locators ahead of time, so you can simply type in your measurement locators directly into this equation box if you will be creating several calculations in WaterTrax. So there's our formula, 1 minus our effluent measurement locator divided by our influent measurement locator times 100. Let's check our formula to make sure it's valid, and it is. And there's our measurement there, TSS milligrams per liter, and our raw TSS value as well. Let's give it a specify our decimal place, rounding, and then lastly our result units, which of course is in percentage. So let's select percent, and let's trigger the calculation. Let's back up and have a look at our results. Demo number 4. There it is. Let's click on it, and once more, you can see that there's several results dating back to 2011. There's the decimal place rounding, 70.4, and these are all, of course, in percentage. The units is in percentage. So we know that the calculation is, again, working as it should. So as you can see, the tool is very, very handy. It's a good tool to use, and I do recommend that you give it a try. And please feel free to pass along any feedback to us. So let's go back to our presentation and do a quick recap of what we've covered. Once again, the Formula Builder performs predefined or customized calculations automatically so that you no longer have to manually do these yourselves. The tool supplements the existing calculated measurements to give you access to more formulas and calculations. The key features of the tool are the generation of regularly scheduled calculated results, the mapping of calculated results to actual measurements within your account, thus eliminating the need for any re-entry of data. Being able to review and report your results out of WaterTrax, having the flexibility to define units and your decimal rounding preference, and receiving real-time alerts. Each time the calculations are processed, you can output your results using any of the WaterTrax reporting tools such as the Water and Wastewater Data Report, the Tabular Report, the Water Quality Report, the Data Export, and the Custom Data Export. So to sum it up, the real highlight of this tool is the fact that it is fully automated, it's easy to set up, and it will eliminate the need for you to use any other third-party tools to perform your calculations. So feel free to try out the new tool when you do have a chance and let us know if you have any questions or feedback about it. So I do hope that you found this webinar helpful, and we look forward to hearing from you soon. Thank you.